5.1.
Yes, 5.1.
In 5.1, I think one doubt I am having, madam. If
Yeah.
he,
In which
I,
question?
1 second, madam. Here,
How to solve this 5-number question?
This one?
Yeah.
Okay.
not a function.
Okay. So what is the question? We have f from 0 to 0 infinity to r. Which of the following is not a function? So we have to check which of the following is not a function, right? So we can recall the definition of function. So what was the definition of function? Any one of you? Just
It has to pass the vertical line test.
yeah, not the test. I want the definition, that domain and codomain one.
Function is a mapping between set domain
Yeah, to codomain,
to
right?
codomain.
Such that each element of the domain should map to a unique element in
Unique
the
and
domain.
unique and
Means
unique. Each, every, and unique.
yeah,
Each and each element and unique. 2 conditions.
yeah. Each element of the domain D should map to a unique element.
Unique element in the codomain.
In codomain, right? That means this is not allowed, right? Here one element is going to 2 different elements. This is not allowed, right? Because of the word unique element, right?
Yes, ma'am.
Yeah. Now can you see which option can we discard? I mean, which option is not a function?
Fourth option is a function. Third option is a function. First option is a function. That is confirmed. Linear function, quadratic function, constant function.
What about the second option?
Second option only, it is
It is
plus or
not a
minus.
function,
It's
right?
a root, yeah.
Yeah. So every point will go to 2 different points for this one, right?
One will go for plus, one will go for minus.
Yeah. So this is an example of not a function, right?
Yes,
So
correct.
the second option is correct. Is it fine now?
Yeah, I solved it, madam. Minus only one wrong. Fourth question was wrong. All others I was able to understand.
Okay.
In this, actually, I have even given function if the first option is correct. It's called 1-to-1 when f x1 equal to fx2, then x1 equal to f2. We have discussed that, no, madam. Like one way of telling is when x1 is not equal to x2, then f of x1 is not equal to f of x2. Then it is called 1-to-1 function. Fourth option.
Fourth option.
Excuse me, ma'am.
No. Yeah.
What is the basic root of function? How to understand? Actually, it's a long time back I'm understanding this function. How to catch this function?
So the thing is, the definition of function, as I said, so each element of the domain D should map to a unique element of the codomain. So this is a definition of function. That means if this is our domain and D is our suppose codomain, okay. If there are 5 points and there are some number of points, you have to map each inputs. Like each input you have to assign with some output. Okay. So if I assign this in this manner, so is this a function?
Yes.
No, this is not a function because this one is left, right? We have to
But
assign
each one is unique, right? I'm matching
Yeah.
with different.
No. See, The first condition is we have to assign each input with an output. Okay, that means each input, each member in the domain should have a mapping. Okay, this is the first condition. And the second condition is the image should be unique. This is not a function because of this element has no image. Okay, and if I draw this here, this is our domain, this is our codomain. So in our domain we have three members. If we assign like that, is this a function?
No,
Why?
because one function has two values,
One
same
element,
value.
one element has two different image, right? This
Yeah.
has two different image. So this is also not a function, right? But if I draw a picture like that, is this a function? Is this a function?
The function. Yes.
This is a function, right?
How?
Because image, that means two element can go to one element, but one element can't go to two different elements. Okay. Okay. So
Please repeat it again.
two element from the domain can go to one element in the codomain. But one element in the domain cannot go to two different elements in the codomain. Is it clear now? Like
Yes, ma'am.
one, yeah.
Till now it is clear.
Okay, that means the first point you have to remember is each element of the domain should have a image. Okay, like for each element of the domain you have to assign a image from the codomain. And the thing is, one element from the domain cannot go to two different places, but two different element from the domain can go to a single place in the codomain. Okay. Okay. So this is the three things you have to keep in your mind in order to define the function. Is it fine now? Okay. Okay, so we were solving the fourth question, right?
Yes, madam.
Okay.
So function, fourth option is
Okay,
it's
let us come one by one, right? Let us start from option 1. So
yes,
so option 1 is like a function f from x to y is called 1 if f of x1 is equals to f of x2, then x1 is equals to x2. So what do
this
you
is
think?
true, no?
It is true, right? It is by the definition, right?
Yeah, but the accepted answer, it is not given.
We want the false one, right?
Okay. Okay, madam.
So this is not an answer because this is
Okay.
true, right?
Yeah.
Okay. The second option is one-to-one function are not always reversible on their range. What do you think about it?
It is
No,
correct.
This is correct, right?
Yes.
Yeah.
No, this is not correct. This is not correct because we have on their range. Okay. So if it were on their codomain, then there was a chance that the function might not be onto. But we have the range here. That means every element in the range should have a pre-image, right? That means every function is basically onto on their range, right? Am I clear?
One-to-one functions are not always reversible on the range. So if it has to be false, it should be one-to-one functions are always reversible on the range.
Yeah.
Yeah, in range, yes, because once it's one-to-one, then we know f of x1 equal to f of x2, then x1 will be equal to x1.
Yeah.
So,
So
x1,
to be reversible, we want 1 1 and onto, right?
yes, 1 1 and onto.
So 1 1 is given, and because it is on their range, that means it will be automatically onto, right?
Onto. Yes, ma'am,
So
correct.
this statement is also a correct statement. This is a true statement, right? I mean, this is a false statement. Sorry.
If it is not, not was
Yeah.
not there.
Yeah.
One function are always reversible
Are
on the
always
range.
reversible on their range. So this
Yeah,
statement is
since
a false.
not is given, so that is why it is false.
Because of the not, this is a false statement. Is it fine? Any doubt?
No, ma'am.
Okay. So what about the third one? If a function fails the horizontal line test, then it is not reversible. This is true, right?
It's a statement, correct.
It is a statement. So it is a true statement. That means this is not a correct answer. Okay. What about the fourth? A function f from x to y is called 1 to 1. This is again one false one, right? So this is also right. Right? So if we want to take the contrapositive of this statement, so this is basically if x1 is not equals to x2, it will imply f of x1 is not equals to f of x2. Okay. But here we have the ulta one. That means f of x1 is not equals to x2, then x is not equals to x1. Then the function is called 1, 1. This is wrong, right? Because you can take any function. For example, f of x equals to x square. Okay.
Ma'am, x square is not a one-to-one function.
Yeah, yes, right. So this is not a 1 1 function. We know that, right? Okay. So we know that 4 is not equals to 9, right? And it implies that obviously 2 is not equals to 3, right?
Okay, madam.
So this is the functional value of 2. This is the functional value of 3. So basically, this is a not one. This is not a 1 1 function, but this is satisfying this condition, right?
Okay.
Okay. So this statement is basically false. That means if a function is not a 1 1, then even the function will satisfy this condition. Okay. Okay. This is a well-definedness condition. Okay. Any doubt?
Okay, madam.
Okay. Fine. Okay.
Can you explain why f of x equal to x square?
Yes.
Why f of x equal to x square is not a one-to-one function?
So you can check it with the horizontal line test, right? So
Parabola.
Yeah, x square means we will get a parabola, right? So if you draw any horizontal line, it will cut the graph at 2 different places. That means it is not a 1 1, right? Or else you can see the value of 1 and the functional value of 1 and minus 1 are same.
Yeah, but that is different by the domain, right? Like if I say it's going to start from 0 to infinity, then it is a one-to-one function.
No. Here they don't mention something like that, na? So we'll take the whole domain. Okay. You can restrict the domain of any function and make it 1 1, but the original domain I'm talking about. Okay.
Okay.
Yeah, if you restrict the domain from here to all, then it will be 1 1. But in its original domain, the function will not be 1 1, right?
So always consider minus infinity to plus infinity.
Yeah. So if they are not asking about any restriction, then you have to consider the original domain. Okay.
Got it.
Okay. Yeah. Next.
Excuse me,
Five.
ma'am.
Yes.
For 5.1 others, I was able to understand.
Okay. Okay.
Ma'am,
5.
I have a sorry to interrupt the class, but what are you discussing today in this like this?
Today, basically, we will pick all the doubts from week 5. Okay. Okay. What about 5.2? Any question? Do you have doubt in any question? What about the 4th question? Solved it? Do you have solved it?
Ma'am, it's a difficult one. Can you take us through this? Like the fourth one?
Wait, what?
If it's a difficult question, can you take us through that fourth question?
Difficult question.
No, if the fourth one is like little difficult, can you take us through the question I'm asking?
Yeah, sure.
Yeah. It's,
Okay. So what about the first option?
Which of the following statements are incorrect?
Yeah. So is the first function 1, 1? Is the first function 1, 1? We will go by definition. Okay. So,
No, it is not 1, 1.
okay. So let us see. We can rewrite this as we have 4x plus 3. So you said it is not a 1, 1. Do you have any example? I can't hear you. Can you?
Hello.
Yeah, yes.
Here it is. Denominator is 3 and numerator is 5. So it is not possible. Means it's a simple hint.
no, they're not including that 5 by 3. It's
Yeah,
R minus
5 by 3 is out of the domain, right?
out of the.
This is the domain, r minus 5 by 3. Okay. The function is defined in this domain, r minus, because this point should not be 0, right? In order to define the function f. So the domain is basically r minus 5 by 3. Okay. So we have the function 4x plus 3 by 3x minus 5. We can rewrite, we can balance this function, right? We can rewrite it as 3x minus 5 plus x plus 8, right? Right? We can rewrite this in this manner.
Yes.
Yeah. Then okay, so this is not a helpful one. So we can do something else. We can take 1/3. We can multiply it with 3. Okay. 4x. 4 we will take as common. So we need minus 20. Okay. Plus 23 by 3x minus 5. So we will get
The denominator x minus 5 by 3. Yeah, continue. Sorry, sir.
okay. We are dividing it and multiplying it with 3. Okay.
One thing what I was thinking, I have done little bit late. Multiply and divided by 3x minus 5 in both denominator and numerator.
Mhm.
So we'll get 3x minus 5, the whole square will be there. And if you multiply, my notes I just set up.
Okay, you can share your thoughts. Just take the photo of your note. Okay.
Anyway, you complete this line of
Yeah,
thinking.
yeah. So we can take 4 as common. Then we will get 3x minus 5 plus 29 by 3x minus 5. Right? Right? Then we can express it as 4 by 3 plus 29 by 3 into, that means 9x minus 15. Is it fine? This new expression of the function?
4 by 3, then 3x. Why 9x plus minus 15 has come, madam? We are just
This
dividing.
3 will be multiplied with this, right?
3x minus 5, yes.
Okay.
So we will get 9x minus 15. Is it
Okay.
fine now?
Okay.
Okay. So this is
Ma'am.
our new function, right?
Yes, madam.
Okay. Now let us take, as per the definition, if we know if x1 is not equals to x2, okay, so we will take f of x1 is equals to f of x2. Okay, we want to prove it 1 so we have to, in the final we have to prove x1 is equals to x2, right? This is our aim, right? This is our aim, right?
Yes, madam.
Yes.
Yeah. So we will put the value. So this will be then 4 by 3 plus 29 by 9
Minus 1
minus 15.
equal to 4 by 3 plus 29 divided by 9x2 minus 15.
Yeah. Then we can cancel this 2 out, right?
Yes, madam.
And 29 also we can cancel. Then we can flip them. So we will get 9x1 minus 15 equals to, right?
Yes, madam.
Then we will get 9x1 equals to 9x2, right? Because 15 can be cancelled out from the both sides. Again,
X1
9.
equal to x2.
Yeah. Okay. So we just balance the function little bit and we can prove if f1, f of x1 is equals to f of x2, then x1 is equals to x2. That means the function is a 1 function, right? Any doubt in this?
No, madam.
Okay. So it is clear to everyone, right?
Yes,
So all
ma'am.
this
Thank
necessary
you.
to actually understand, I mean, do this sum.
What?
Is all this required to do this sum, or shall we directly say that if I
Yeah.
put
See, the thing is, this is a process. I mean, in this process, you can solve this type of thing. Okay. So if you do this, it even like 3 to 4 times, you will be used to it. Okay. So this is one of the process. I will show you different process to reach to the
got it,
destination, right? So this
got
is
it, got it,
yeah.
got it.
Okay. So we basically prove the function is 1 as this option is incorrect option, right? We have to choose the incorrect one. So this is the wrong answer. What about this?
Madam, this is 1 to 1. No, so correct answer, no, madam.
No, we have to choose the incorrect one, right?
Okay, you have put a cross mark. You have not put a tick mark. Okay.
Yeah.
Okay, madam.
So the second
Mx
option
plus
is
c
also
is basically a linear
a
line. So
line,
it
right?
is 1
Excuse
to
me,
1.
ma'am.
Yeah.
Excuse me, ma'am. What we did with this x r and 5 by 3
This.
is 1 to 1. For this, yes, equation, what we
Okay.
did for this?
So this is basically the domain of the function f. Okay.
X is domain of r by 5 by 3. What we did for this?
Okay, that means the function is from r minus 5 by 3 to some codomain. for any function, we need a domain and codomain, right? Right. So at each point of the domain, the function is defined, right?
Okay.
Domain means the set of all input. So
Yes.
this is the set of all input for the function f. We can't take the point because at this point, this portion in the like denominator portion will be 0. That means some point by 0. So this is a undefined number, right?
Okay.
So if you take 5 by 3 instead of x, we will get some undefined number. So we can, that means at the point 5 by 3, we can't
That's
define the function, right?
That's not 0 by 0, ma'am. It's 3 by 0.
Yeah, this is some finite number. No, not 0.
3
Okay.
by 0 is infinity, right? Like we can define that, right?
Yeah, we can calculate it. So 4 into 5 by 3 plus 3, this is a finite number by 0, right? So that means at the point 5 by 3, our function is not defined. And we know that the function should be defined at each point of the domain. And we can see that at 5 by 3, the function is not defined. So we will exclude the point from the real line. So
infinity is not defined, is it? Like
yeah,
infinity,
like some finite number by 0 is not defined. Okay.
okay, so finite number by 0 is actually infinity. So infinity
Yeah,
is
it is
considered as
not actually infinity. It is something tending towards infinity.
Undefined.
okay.
Undefined. This is undefined. Okay.
Okay.
This is something tending towards infinity, which is undefined. Okay. So the thing is, we can't take any point in the domain for which the function becomes undefined. So we will exclude the point from the domain. Is it fine now?
Yes.
Okay. So the second option is a line and m is not equals to 0. That means it will not be a horizontal line, right? Slope is not 0 means it will not be parallel to x-axis. So we will get line like that. It will always pass the horizontal line test. So this is a 1-1 function and this is a incorrect. That means the answer is incorrect, right?
Yes, ma'am.
Yeah. A quadratic function is always 1-to-1. This is clearly a incorrect statement. So this
Yes,
is a correct one, right? And
Yes.
this is also similarly, right?
Yes.
Okay. Next. What about this one?
Yeah, I got one wrong
Yes.
in this one.
Yes, ma'am. I have doubt in this question. Question number 3.
Okay. Let us solve it. What about the first one? Is it decreasing?
We have to check the highest x power. So it is 2 and see for the draw the end.
Okay, the first thing you can do is the first option is a parabola, right? So we know that, and the domain is the whole R, right? So we know that parabola is half increasing, half decreasing. So it will never be the correct option. So we can discard it, right?
Yeah, on a general note, if you are seeing increasing or decreasing, when we write the what do you call end lines, that also then also we can draw a graph for all these four, no, madam?
Yeah, sure.
Okay.
But we can also check it by the definition. That means
Correct,
if,
madam.
yeah, so if x1 is greater equals to x2, then minus 3x1 will be less equals to minus 3x2, right?
Yes.
And 7 minus 3x1 is less equals to 7 minus 3x2. That means the reverse inequality, right? So this is a decreasing function. Is it fine?
Yes, minus is there. That is why it is decreasing.
Yeah.
X is having a minus.
Yes.
Yes, madam.
Similarly, if x1 is greater equals to x2, x1 cube will be greater equals to x2. But if I multiply with minus 2, so minus 2 x1 cube will be less equals to minus 2 x2 cube, right? Again, we are multiplying with something negative, so inequality will be reversed, right?
Yes, madam.
Yeah.
I have put 1 by x also as correct answer.
No, actually 1 by x, the graph of 1 by x is like that. Okay. So in a portion of the domain, it is increasing, and in another portion of the domain, it is decreasing.
Okay, when you take negatives, only positive side, and I have taken.
Yeah.
So 1 by
So here the
1
domain
by
is
1,
R
1 by 2, 1 by 3,
yeah.
1 by 4, 1 by 5. Actually, it is decreasing. Only when it is positive. Okay.
So
So
because we have to check the domain also, right? Here the domain is given as only R minus 0. That means we have to consider both the negative and positive side. Okay.
Okay, 1 by minus 2 will be minus 0.5, 1 by 4 will be minus 0.02.
So no, we can check the, some one negative point and one positive point. Okay. For that, we will always find the negative point to be something less, and the functional value of positive point to be something greater. So it will again like continue the same inequality, right? That means
Okay.
minus 1 is less than 1, and sorry, minus 2 you can take, and minus 1 by 2 will always less than 1 by 2, right?
Correct.
That if you take one negative point, if one positive point, then you can find the increasing inequality. So this is not a decreasing function. Is it fine now?
Yes, madam. Yes, madam. I just calculated 1 by 2, 1 by 3, 1 by 4. Then it is decreasing.
Yeah. So this
So,
is decreasing in 0 to infinity. Also, this is decreasing in minus infinity to 0. But if I consider the whole domain, that means R minus 0, then it will not be a decreasing function. Okay.
okay. So, no. Okay. In minus side also, it is decreasing only, no? Actually.
Yes. In this is the beauty of the function. In minus side also, it is going in the downward direction, right? And in the positive side also, it is going to the downward direction. That means if you separately take the minus portion, minus side, then it will be a decreasing. If you separately take the positive portion, then it will be a decreasing. But if you take the whole domain, R minus 0, then it will not be a decreasing function.
Then what type of function this is, madam? Whether it
Neither
is
increasing nor decreasing. Okay.
How can some function be like that? Neither increasing, some it has to either decrease or increase.
It can be like that. There are plenty of function which are neither increasing nor decreasing. Like if you part the domain, so in some part of the domain it may be increasing, in some part of the domain it may be decreasing.
Yeah, but like polynomials, we can see like it will go up and down, up and down. That we can understand.
Yeah.
So it's saying it's neither decreasing, it is both decreasing and increasing. But this is a very peculiar function, 1 by x.
Yeah, this is in some particular domain, this is decreasing, but in the whole domain, this is not a decreasing function.
Okay, this will maybe called as neither increasing nor decreasing.
Not decreasing. Yes, right. So there are plenty of functions which are neither increasing nor decreasing. This is one of the example. Okay.
So such type of questions, basically, if entire R is there, then you take one negative x and one positive x and start doing like what you have done now. Less than minus 2 is less than. Okay, what happens when you put the function?
Yes. So when you are checking in whole domain, that means you can take any random point from the domain, right? And we can take some random point for which it is not satisfying the definition of decreasing function, right? So we can conclude that this is not a decreasing function.
So decreasing function definition is as from left to right when x is changing, f of x has to come down. It should be lesser.
Yeah. Less equals to f of x. So this is definition of decreasing function.
Yes, madam. So such type you actually go with the definition only. You try to solve using definition.
Yeah, sure. So
yes,
that is why we did with definition, right?
Correct. I'm just repeating what you are telling, madam.
Yeah.
I was thinking we can try with graph and all. So that is not required for this.
No. Sometime you may have to analyze the graph, but sometime you like it's for your like whichever you are finding to be more flexible.
Because when I tried with graph, I was wrong, no? Because the fourth option came as correct option with graph when I use, because this is the
But
type of
you
graph
have
we got.
drawn the half graph, right?
Yeah.
That's the problem.
Yeah,
So,
but again, even when I drew only half, but you also drew full, but still it is decreasing.
no, yeah, it is decreasing, but that's the thing, na? It is part-wise decreasing. It is decreasing from 0 to
Yeah,
infinity.
now I understood, madam. After you
Mhm.
explained, it was
Yeah,
clearly explained.
so you
Now I
have to
can
observe
understand.
it properly. That's the thing.
Okay.
Yeah.
Okay. So
For
no
every
urgency.
point you have
So
to.
what I think is we can solve this only by looking at the graph. Otherwise, I don't think we can follow some step and reach the conclusion.
You can
Here we have to see the
draw
graph,
the
and that's when
graph. You can draw the graph, but sometime it may be time taking to draw the graph. So you can also check it by the definition. It's up to you. Whichever you are finding more flexible, you just follow that one. Okay.
no, until we fix some a value from the two domains, negative and true, we will never be able to understand why it is decreasing and not increasing, or it is increasing or not decreasing. It's actually the value which we pick for the x1 and x2. That understanding will be better if we have a domain. That's all I can know.
Okay, so this is a little bit tricky. I mean, once we are taking a negative point and positive point, the functional value of negative points is also less than the functional value of the positive point, right?
True.
That's the thing. That's the thing. You have to do. Is it fine now?
Okay, madam.
Okay.
Yes. Yeah.
Okay. Okay. Next.
Activity 5.3, question number 2 now.
This one.
No, activity 5.3 actually.
5.3 question number.
This one, madam, that for the fourth option, why it is 5.2 only, we'll finish, then we'll go, ma'am.
Yeah,
Fourth
sure.
option, how we have to find out, madam? We have to draw a graph
Yeah.
and
Yes.
do the horizontal test.
Yeah, you can draw the graph and do the horizontal test. Yeah.
Because once just we see as x cube,
Mm-hmm.
it will be like saddle point and all those things will come. So like that
Yes,
I
yes.
tried. But when I saw the answer, it is wrong. It is not a one-to-one.
Okay.
So we have to draw the.
Yeah. So the thing is, if you have some example in your mind, direct example, then you can apply the example. But if not, if you are not finding any example, discard, which can discard, then you have to draw the graph. This is the best thing. Okay.
Okay, madam. And any modulus function is not a one-to-one.
Yeah. So you will find the edge, like reflecting type of thing.
Yes, madam.
Any modulus function is not one.
Okay, madam. Yeah, we can go, madam. 5.3.
Yeah. 5.3. Which one?
Question number 3 now.
This one?
Yes, ma'am.
Okay. So here you have to calculate the powers. So the answer is 60 power 15. Okay. So here basically you have to calculate the powers. Okay. So what will be this
Coming
portion?
different.
What will be the value of this portion? 4 into 27.
27. Yeah. Full power 5.
Whole power 5.
Yes, ma'am.
I was doing is I brought everything into 2 power like 2, 3, and 5.
Yes, yes. That is what
So-
we have to do.
And
So
I also did the same.
we have to simplify it, otherwise we can't do that.
So 2 power 10 into 3 power 15 into
Yeah.
2
So we
power
have
14.
so from here we have 2 power 10 into 3 power 15. Then 2 power 2 into
14.
7, right?
2 power 14, 5 power 3,
Power 3.
2 power 3,
2 power 3.
3 to the 6, 2
Okay.
power 6.
5 power 6.
Then
Then
2 power 6, madam. Okay.
Yeah, we can again break it. So
Okay.
if I sum this, then we will get 2 power 24 into 3 power 15 into 5
5 power
cube into 2 power
2 power
6 into
6,
5 power
5 power 12. Yeah. Up to this step, I was able to come. From there, how to go back to the answer only, I did not know rather.
Okay. So 2 power 24 plus 6, that means 2
2
power
power 30.
30, right?
3 power 15. 5
3
power
power
15.
15.
Okay. Now
Right?
we can bring this 30 it as
4
15.
by
4. Madam. Okay. 4 by 15, 3 to the power of 15, 5 to the power of 15.
now we can take it as
Yeah.
4 into 3,
12 5 are 60.
right?
Yeah.
Got it, ma'am. Got it.
Yes. Okay.
So this is the answer. Is it fine?
Yes,
Got
madam.
it, ma'am. Thank you.
Next. This one, what about this one?
Yes, ma'am. I have got also question number 5.
This one?
Question number 5.
Okay. So exponential function means we will have a base to the power x. So only the
Yes,
second option is contradicting the definition, right? So the in case of exponential function, only the exponent is variable, right? For the second function, we can see the exponent is not a variable here, right? The base is variable here, right?
What about our option number 3? Fx equal to 15 upon.
So this we can write it as 15 into 8 power minus x, right? This is again an exponential function. Okay.
Sorry, ma'am. Please explain again.
15, this we can write it as 15 into 8 power minus x, right?
How,
We have
ma'am?
15 divided by 8 power x. That means if you want to multiply it, the power got minus, right? This is the basic mathematics things.
Okay, ma'am. Okay. Got it, ma'am.
Yeah. Okay. So 5.3 is fine, right?
Yes, ma'am.
Okay. What about 5.4? Anything in 5.4?
No, ma'am.
So
Actually, I
all
didn't.
ma'am one by one.
Also.
So you want me
Actually,
to
I
solve?
didn't.
Yeah, at least this one, number 1.
Okay. So we have f from R to R is defined by f of x equals to 3 power x plus 20. Which of the following is range and domain? Okay. So for exponent, this is another exponential function, and for exponential function, we know that the domain is the whole real line, right? So this is the domain, right? At any
Yes.
real number, we can define the function. So this is our domain. Okay. So when
And
when x is tending to infinity, then 3 power x plus 20 will be tending to infinity, right? If x is tending to minus infinity, then 3 power x will be tending to 0, right? Right?
yes,
Right,
madam.
ma'am.
Yes, ma'am.
And 3 power x plus 20 will be tending to 20, right?
Yes, ma'am.
Yes.
That means our domain becomes from
Domain
20 to, sorry, codomain
code
or range. This becomes
fourth
20.
option.
Yeah, 20 to infinity. That means this option is the correct one.
Ma'am, can you draw the graph for this function, ma'am?
Sure. So typically, exponential function graph looks like that, right? So whenever you have plus 20 means you have to shift it in the upward direction with 20. So it will look like that.
Okay. Thank you.
So you have to shift it bit in the upward direction in 20 unit. Okay.
Okay. Okay, ma'am.
Yeah.
Can you draw one more graph for exponentially decreasing function? That is 3 power. If the base is less than 1, I think.
3 power minus 1 minus x.
No.
Then this one.
This instead of 3, if it is 0.5.
Okay. So 0.5 power x.
Yes.
Okay. So in this case, we'll find this type of like if it is less than 1,
The
then
decreasing
we'll
function.
Decreasing function. Yes.
Okay, ma'am.
Okay. So the another thing is if you have 0.5 power x, that means you can write it as 1 over 2 power x, right?
Yeah.
So it will be 2 power minus x.
Oh, if if the coefficient of x is negative, then it is a decreasing function only.
Yes, right.
Okay. Thank you.
Yeah.
Ma'am, can you please also draw a function of exponential function with coefficient and adding constants if suppose
Okay, so the funda is like if you are adding some positive number, so
okay.
see, typically this is our exponential function when x is positive. Okay. If you are adding some positive number, you will find that means it will shift in the upward direction
Okay.
with the constant unit, right? Here
Yeah.
it is 20. And if you are like subtracting some number, then it will be same thing, it will be in the downward direction. Okay. So basically you have the same figure. If you are adding some positive constant, you have to shift it in the upward direction bit with this unit. And if you're subtracting a constant, then you have to shift it in the downward direction. That is it.
So for similarly for this decreasing function, can you?
Same.
Yeah.
Like this is a typical figure. If you are
Yes.
adding something, that means you have to do this.
Okay.
If you are subtracting something, that means you have to do this.
Okay.
So the thing is, like if you are adding this, that means you are scaling it up, right?
Yes.
So you have to shift it in the upward direction. And if you are just subtracting, that means you are scaling it down.
Okay.
So you have to shift it in the downward direction bit. Okay.
Oh, okay, ma'am. Thanks, ma'am.
Yeah. So when we are adding or subtracting some number, that means it's basically scaling. Okay. The same figure, you have to scale it up or down. Okay.
Then in the case of subtracting, you are just shifted the bottom of x-axis. Can the x-axis, can the exponential function graph intersect x-axis?
What?
And in case of subtracting,
Mm-hmm.
you are just you just shifted the graph bottom the x-axis. Can the exponential can the function graph of exponential function intersect x-axis?
Yeah, why not? Like if you draw the graph, you will get an idea about it. Okay, this is not the perfect one, so you can draw the graph. Okay. So we are scaling it. So in that case, we may sometime find some function which are like intersecting the x-axis. Okay.
Okay, ma'am.
Yeah. Okay. Anything else in the 5.4 portion? Anything else?
Third sum, ma'am. Thank you.
Third sum, ma'am.
This one?
Yes.
Okay. You just tell me, what about the first one? I just told you. Minus x means it is decreasing, right?
Yeah. Decreasing function.
Yeah.
Yeah,
And
it's 1 by
A
8
is-
power x. It's a decreasing function.
Yeah.
Mm.
Similarly, the third option, this is again decreasing.
Yes.
Yes, ma'am.
Yes, ma'am. Yes, ma'am.
This is one incorrect answer, right?
Yes, yes, yes. Third option is one incorrect option.
Yeah. And the second is A is positive, that means it is increasing, and G function is also, the base is positive, that means the G function is also increasing, right?
Yeah, yeah. I got the. I can understand that second option.
Yeah. And what about the fourth option? A is less than 1, that means decreasing, right?
Yes, it's a decreasing function only, no?
Yeah.
And then how it come has the same property as because
No,
once
right?
I want.
Yeah, that's why it will be an incorrect option. So this is a
Oh,
this is a
sure. Yeah, I'm okay. Yeah, yeah.
It's less than 1, but it's more than 1.
Yeah.
Yeah, 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 yeah. Also, it's a right. It's a wrong option. Incorrect option.
Yeah.
Yeah, yeah, yeah.
Okay, fine.
Okay, ma'am. Fine, ma'am. Fine.
Good. So what about the next one? Is it fine?
Yes.
Okay. Then we can move to 5.5. Okay. What about 5.5? Mm-hmm. What about 5.5? Any doubt?
Solve, ma'am. First question.
Which one?
First question. Yes.
This one?
Yes.
It's a simple max. I solved it, but not using our whatever we learned. 5% per a year.
Mm-hmm.
So 5% is about 50. Then 55% will be 12.5. So it will be 1062.5, something like that. Yeah, 157.625.
Yeah.
No,
11102.5.
25. Yeah, 5% of 1000 is 50. For next year, it will be 52.5. So 2 years, it is 102.5 plus 1000.
Hmm.
Like simple interest, compound interest, max class,
Got it.
7th standard, 8th standard.
Okay.
With
So
that
Got it.
they
Got
have
it.
given the formula, you just have to apply it. Okay.
Okay, ma'am.
Yeah. What about the second one? Third one? Anything? What? Activity 5.
Ma'am, please solve E option. How to calculate E?
This
Yeah,
one?
second question, third question,
This
second
one?
question. Yeah.
This one?
Yes, ma'am.
Ma'am.
Okay. So the slope of the tangent line at, okay, so the slope of the tangent line is derivative of the function, right? So we have e power x, this is the function, so the slope will be f dash x, that means again e power x, at x equals to 1, this will be e, right? So this is one correct answer. Similarly, you have to calculate the derivative. So what will be the derivative of this function? 2x plus e, right? At x equals to 1, the slope will be 2 plus e. So this is the incorrect option, right? Can you do the other two?
Repeat again, ma'am. This concept.
Slope of a function at some point means you have to calculate the derivative of the function at that point. Okay.
Okay, ma'am.
You have given function, you just have to derivative it and you have to put x equals to 1. Okay. Okay.
Ma'am. Okay.
Yeah. Similarly, this is incorrect and this is correct. Okay. Next. Next. 5.6. Solved it or not?
No, I did not solve, madam.
Okay. So, anyone? Okay, because you haven't solved it, so you just take your time to solve the activity question. We can go to the practice assignments. Okay, activity questions are typically not that tough, so you can solve it if you just try to solve it. So we can go to the practice assignment. Okay, what about the first, which is function and which is not? You have to check. So we can take the vertical line test in order to determine a function or not, right?
F6 is not a function.
F6, yeah, F6 is not a function, right? We can check the correct answers also. Yeah, so F6 is not a function. This is the correct one. Simply,
F3, no, yeah, we'll see the answers, but F3 is not a function. F3 is a straight, okay.
F3 is a function, right?
Straight line,
It will
okay.
pass the vertical line test, right?
All others will pass vertical line test.
Yeah, so except F6, all the graphs are functions, right? Right?
Okay.
Yeah, so only F6 is not a function. The second option also we can check 1, 1 or not. Horizontal line test.
F1 is not 1, 1, only F2 is 1, 1.
Yeah,
F4 is 1, 1.
only F2 and F4 is 1, 1. Okay, F2 and F4 is 1, 1. Okay, this is correct. Strictly increasing or decreasing in the domain, you have to check.
That straight line F2 is strictly decreasing, and F2 and F4 strictly decreasing.
Yeah. See, this is the correct answer. Okay, this is very easy, right? What about the fourth one? You just try to solve it now. I'm waiting. I'm giving you some time. You just try to solve the fourth question. If you are finding difficulty, I will solve.
Ma'am, I have a doubt on question number 2. Can you go to question number 2?
Question number 2. This one?
Yes. Yeah.
Yeah.
So, or the answer is F2 and F4. Can you go to the F2 like on the diagram?
Yeah. So this is the F4, right? And you can draw any horizontal line. It will cut the F4 at only one point, right?
What if it gets parallel over the... Okay, it's -4 and +2. Okay.
Okay.
I was thinking if it is going to go parallel over the... Maybe, okay, got it.
No. This is just the range.
If it's between -infinity and +infinity, then this can't be a 1-to-1, right?
Why?
Because that line, like let's suppose we look at the curve on the left side for F2, it might go on the, might stretch across on a straight parallel line.
F4 is a straight line, right?
No, not F4. F4 I understand. F4 is a straight line. F2.
Okay, F2.
If you see,
Okay,
it's
so
curved.
it depends on the figure, how the curve move or
Correct.
not. Yeah, it depends on
But
the
since there is a decrease, I mean, there's a decrease in slope there. If that's the case, then it will definitely there will be a line towards infinity where 2 points will have the same value, correct? Since this is restricted to between -4 and 4, we are saying that it is 1 to 1.
Yes. Yeah, you have only have to check from -4 to 4.
-4. If it is -infinity to +infinity, this will not be a 1-to-1, correct?
Yeah. So it depends on the figure. We can't comment anything.
No, even see, let's suppose there is a very slight curve, but that curvature will lead.
No, it can be also in this way, right? That means in this way, and this, in this way.
Oh, okay. After that, it becomes linear. Okay.
Yeah. So we
Got it,
can't
got it.
comment anything before seeing the whole picture. So because we can see from -4 to 4, we can comment from -4 to 4. Okay.
Let's suppose the same figure F2, on left side it is x is equal to minus infinity, and right side it is x is equal to plus infinity. What will be your idea on that?
Then also it is a 1-1 function.
How can that be, ma'am? Because there's a
And
curvature.
you just draw any horizontal line. It will cut at least at only at one point, right?
I'll tell my thought. Since there is a curvature between minus infinity and plus infinity, and that is clearly represented in the figure, in that case, the curvature will lead to same 2 points in x having the same value in the y.
Why?
Because it's
How?
infinity, no? Like there is a curvature and we are coming it to infinity.
Okay, one is going to infinity, one is going to minus infinity. How we are finding the same? I mean,
No, I'm looking at the same points in the whether let's take 2 points in the plus infinity or 2 points in the minus infinity.
okay.
Since there is a curve here, my point is like at some big value, 2 points will have the
No,
same.
see, you are thinking it in some different way. This is not the right way. I mean, if you can find exact 2 points, then it is fine. But from the graph, it is clear. I mean, when you are drawing a horizontal line and it cuts the graph at one places, means the graph on like each point has only one unique image. Okay, that means the graph doesn't have any like repeated pre-image for any point. Okay, so you don't need to think that much complicated. Just check your horizontal line test. Okay.
Well, we'll just be separate.
Is it fine?
Yeah, my doubt is still there, but I'll check on my side. I'll do my research.
Okay, you just tell me once again your doubt.
No, my doubt is, see, F4, look at F4, no. F4 is a strictly linear line. Okay, so that we are very much clear that that line is going to be, the slope of the line will remain the same. So that line will always have two different values for two very near values of x. It will definitely have two different values. F4. F2, since there is a curvature, and if we are extending that to the domain of that curve to minus infinity to plus infinity, it's flattening out, isn't it? The curve is going top and then it's going to flatten out. That's the idea of that curve.
No. See, if it is flat after some time, then it is fine. But if it is not a flat,
here it is not flat because it's the domain is between minus 4 and
I'm saying about this portion only.
minus 4 to plus 4, we both are like same only. We have the same idea. But the point is, if it is going to be from minus infinity to plus infinity.
Okay, I got your problem. So if it is flat after some time, then it will not be 1-1 in minus infinity to plus infinity.
That's exactly because since it's minus infinity to plus infinity and the curve is bending, even a slight curvature on the curve will lead to some area where two very near points will have the same value. That's my argument.
Okay, I got your point. So if it is flat after this boundary, then it is not a 1-1, but it may be like that also, right?
Yeah, that I understood. Yeah, it might be linear. That's what I'm saying. If it is,
yes.
Here it is not mentioned, but if the domain is mentioned as minus infinity to plus infinity, that's when my argument is there.
Okay. So the thing is, we have to check it. The domain is -4 to 4.
Got it.
So I have to check only for -4 to 4 for this problem. Okay.
Got it.
Yeah. Okay. So have you solved the fourth one? Anyone?
The 2 I'm not able to understand, ma'am. Why it is equal to 2? The T1 and T2, when you put that in the minus lambda into T, so we can say minus lambda
Okay.
into T1.
Let us check. So we
Okay,
have given n of T1 is half of n naught. That means n naught by 2, right? Right? Now if I use this, right? Then e power minus lambda T1 by e power minus lambda T2, we will get n naught will be cancelled out. So 1 by 2, 1 by 4, right? Is it fine? This will be 4 by 2, right? Is it fine now?
ma'am. Yes, ma'am. Nice. Thank you.
Okay. Okay. Fifth one, similarly we can do. What about sixth one? Our target is we have to first generate the formula of MAX and MBY, then we can check the options, right? How can we generate the formula for MAX and MBY? M is equals to the primary money plus 1 plus rate of interest by 100 power year, number of year. This is the formula, right? This is the formula, right?
Ma'am.
Yeah. So MAX, that means in the bank A, we have, so we first deposit
Some
P.
amount.
Yes.
Yes, some amount P.
Yeah. And this is the interest rate, and this is year, right? And sorry, when you're using X, that means X is the number of year, right? So we know we have P 1 plus 10 by 100 power X, right? Right?
Yes, madam. And after 10 years, she withdraws the amount. So 10 is given.
Okay. So after 10 years, we will take the amount. That means after 10 years, the amount will be 1.1 to the power 10, right?
Yes.
And then we will deposit in bank B. That means this is the primary amount for bank B, right?
Yes, madam.
So MBY will be first primary amount power 10, then the same formula. So for bank B, what is the rate interest? 12.5.
12.5.
5 by 100 to the per year, right?
Yes.
Now we have both the formula, so now we can check the answers, right? Right?
Yes, madam.
Okay, now you can do it by yourself, right?
Yeah.
Okay. Okay. What about this one? So this is again you can do using this. Okay. Yeah, this is the continuation, right? Okay. Here they have given mn, and you have to like put the function instead of mn, then you have to check the options. This is also you can do, right? You can do it. Can you do it?
Yeah, yes, ma'am. Like a composite function.
Yeah, right. Okay, then we have some functions fg. We have to calculate the domain. Let us do it. So what is the domain of f? What is the domain of f?
Not be 0.
Yeah, that means r minus 0, right?
Yeah.
That means minus infinity to 0, union 0 to infinity, right?
Yes.
So m will be equals to 0, right? Similarly, what is the domain of G?
Three.
It should be
Minus 3 plus 3.
N is equals to 3, right?
yeah.
That means the value of m plus n will be 3, right? Right. Similarly, we have to now calculate the range. What will be the range of G? We have to check at the boundary point. That means at 0, at minus infinity, and at positive infinity. So what is the value of m? What will be the value of m? If we can write it as 5 by 2 plus 9 by 2x, right? So when x is going towards infinity or minus infinity, this will going towards 0, right? But exactly 5 by 2 point we will not get, right? The range will be minus infinity to 5 by 2 union 5 by 2 to infinity, right?
Yes, ma'am.
Okay, so the value of m will be 5 by 2 and the value of n will be 0, right? At point 3 we can find 0, right? Right? So what is 2? M plus n 5, right? Any doubt?
N plus n 5 by 2.
M plus n 2 into m plus n, right?
Okay, 2 into n plus n. Okay.
Okay, so this is 5. What about 11th one? We have to compute the domain of the composite function. H is f compose g. So what is the domain of H? You just calculate and let me know the value of m. Compute H. Then compute the domain of H. Can you find? What is H? What is H?
F of g of x 2 m equal to 2. We are getting 5 by 2 will be the g r minus g r minus 5 by 2. So you have to put 5 by 2 in x square y square minus 9. So you will get root of 4, that is 2. Root of that will be g of y will be minus 2. I mean, it will be r minus 2 range.
Okay. So let us first compute H of x. F of root over y square minus 9. Right? So 5 into y square minus 9 plus 9 by 2 into x square minus 9. So what should be the range? X should be not equals to plus minus 3, right? Right? In domain plus minus 3 should not be present, right?
Yes, ma'am.
So the value of m will be 3, right?
Yes.
Okay. So we have f. We have to calculate f inverse. We know how to calculate f inverse, right? Right?
Yes, yes.
So again, we have to calculate the domain of f inverse. Then we have to find the value of m. And then we have to do the 13th one. This is simple, right? So you can do them, right?
Ma'am, I have a doubt in activity 5.9, question number 4 and question number 1.
5.9.
Yeah.
Question number 1.
Yes.
Okay. And question number 4.
4.
Inverse of the function f of x equals to this is this. So inverse we can calculate, right? What is
Yeah, actually, I got inverse of a function.
inverse of the function 1 by x cube is 1 by cube root of x. This is correct statement, right?
Yes.
So this is not the correct answer because you have to choose the incorrect statement, right?
Yeah.
Similarly, we have f equals to this, g equals to this. You have to calculate the inverse of f. What is the inverse of f? So if f is equals to g inverse, then f compose g should be equals to x, right?
Yes.
What is f compose g? F of g of x, that means f of 11 minus 1 over x. That means 1 minus 11 minus 1 over x minus 11, right?
Yes.
That means this is minus x, right?
Yes.
Minus x is not equals to x, right?
Yes.
So this is not a inverse, and this statement is incorrect. It means this is a correct answer.
Okay.
Okay, so this
Okay.
is correct, and this is also correct, right? That means these are incorrect, right? Statement is correct. That means option is incorrect, right?
Okay, ma'am.
Okay.
Okay.
Yeah. First. Okay. So the first is incorrect, right? F inverse doesn't always mean 1 by fx, right? Just for example, x square. The inverse of x square is over root x, right? Under root x, right?
Yes.
So first option is clearly incorrect.
Incorrect, yeah.
Yeah. The domain of the function f is equals to the range of f inverse. This is correct statement.
Correct statement.
Yeah. And the third, for any x equals to a in the domain of the function a comma fa is on the graph. This is right, right? So the reverse fa comma a will be on the graph of f inverse. This is also correct, right?
Yes.
And the last statement is also correct by the
Correct.
definition, right?
Yes, ma'am. Actually, if I forgot my doubt, I started revising for the exam. I marked down the question numbers, but I forgot the doubt.
Oh,
What is it? Okay. It's okay.
okay. You can.
What is happening, madam?
What?
Quiz one revision session.
Okay. So one revision session is Wednesday, that means tomorrow, and another will be on Friday. Okay.
Okay, okay.
So Wednesday week 1 and 2, and Friday week 3 and 4. Okay.
Okay.
Yeah. Yeah. Anything else? Any other doubt? How is your preparation for quiz 1?
Practice assignment week 1/3 sum. I have doubt on that.
Okay. So you can gather all your doubts week wise. As I said, week 1, 2 is on Wednesday, and week
Okay.
3, 4 is on Friday. So gather all the doubts and ask in the revision session. You have to clarify all the doubt in the revision session. Okay.
Yeah, ma'am.
What?
Yes, ma'am. I have one question for mock test. Can you go?
Yeah, you can take the screenshot and paste it in the chat box.
Oh, ma'am. I am not able to paste in chat box.
The thing is, I don't have the mock with me right now.
Then today I asked you this question. Okay.
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 You can, if you are not doing like can do it, then you can like do it via one of your friend also.
Okay, ma'am. I am not able to this question. Then I will be asked to today, tomorrow. Okay, ma'am.
Yeah, you can ask it tomorrow. Sure.
Okay.
Okay. Anything else? No? If not, you can leave. Otherwise, you can ask. Yeah.
Ma'am, in case of reflexive relation,
Mhm.
whether we need to check all the elements in case of
Yes.
that
In case of reflexive relation, you have to check all the same type of pairs are present or not. Okay.
yes, ma'am.
Yeah. Yeah. Anything else? Any other doubt? I'm waiting. If you have any doubt, you can ask. Anything else? Okay. So if you don't have anything, I will end the session.
Huh?